This is page 3 of the math packet. So I'm starting on question 13. This one says that there are 25 servings in a 30.2 ounce jar of peanut butter. How many ounces of peanut butter are in one serving? So 1 means it's a unit rate. So 25 servings in a 30.2 ounce jar of peanut butter. And so they're asking about 1 serving. So the way to go from 25 to 1 is to divide by 25. And so you do the same on the bottom. So you have to take 30.2 and divide by 25. So when you divide a decimal, put the decimal right above to start. 25 goes into 30 once. Subtract, bring down the 2. 25 goes into 52 twice. 2 times 25 is 50. And then 2. And then you can fill with zeros. And that won't work. It's not big enough. So now you have 2. Bring down another 0. And 25 goes into 208 times. So for 1 serving, it's 1.208 ounces. For number 14, Angela earns $6.25 per hour babysitting. Estimate how much she will earn if she babysits for 9 hours. So it's $6.25 for 1 hour. She's going to babysit for 9 hours. So this is just multiplication. $6.25 for 1 hour times 9 hours. And for the decimal, it's 2 places from the right, so do the same in your answer. And so Angela makes $56.25 for babysitting on the weekend. This says, which of the following is not a factor of 84? So factors are numbers you multiply to get a product, so this would be the product. So which number cannot be multiplied by a second factor to get to 84? And so really you're working backwards. You have to ask yourself, is 84 divisible by these numbers? So I know right away 84 is divisible by 2 because 84 is an even number. With 3, you may know this in your head, you may not. If you don't, check it. 84 divided by 3. Okay, and so when you divide 84 by 3, it works out to be 28. So that means 28 times 3 equals 84. So that is a factor. We're looking for the one that's not a factor. 7, again, you may know, you may not. So divide, try it out. 84 divided by 7. And that works as well. So this is telling you that 12 times 7 is 84, so 7 is a factor. And then the only one left is 8, so let's test it. That should be the answer, but let's make sure. Okay, and so you have 4 divided by 8, which does not work. So this is not a factor, so it's it's number 8. Number 16 says, which of the following does not represent the shaded portion? Well, the first thing you need to do is look at this and figure out what fraction is shaded. There are 6 boxes across, 4 boxes down. So this is a 6 by 4 array. So that means that there are 24 boxes in all, and 3 times 6 of them are shaded, so that's 18. So this is 18/24. So now you need to look at the rest of these choices and decide which one does not represent 18/24. So that means which one is not equivalent. So let's simplify. Let's try to get this to be some other fractions. I notice that these are both divisible by 3. So let's do that. So this is 6/8. I don't see 6/8 for any of these, so let's divide again. These are both divisible by 2. So that is 3/4. So these are all equivalent fractions. 18/24 is equivalent to 6/8. That's also equivalent to 3/4. And so again, the question said not. So when I see 3/4, these are equivalent. So that's not a choice. I'm looking for a not. I'm looking for one that doesn't work. I also know that 3/4, when you see fourths, guys, remember, think quarters. So I know 3/4 is the same as 3/4. And if I think about money, how much is 3/4? It's 75 cents. So this one is also equivalent. 3/4 is the same as 75 cents or 75 hundredths. So that is correct. That works. That's not going to be the one that doesn't work. We don't want to choose that. And then when I look at these, I know right away they're equivalent because percents are out of 100. So 75% is 75 hundredths. So all three of these are equivalent and they're the same as 18/24. So the one that is not is 25%. For number 17, Roberta uses 5 beads for every 3 inches of string while making necklaces. So here are the important pieces. It's 5 beads, 3 inches of string. That's what we need to pay attention to. So which graph represents the ratio of necklace string to beads? Remember, when you see ratio, you have to keep these words in order. You have to make the numbers match the order of the words. So we need the necklace string first, and then the beads second. So the necklace string is 3 inches, and the beads is 5. So you have to have the 3 first and then the 5. So when you look at these graphs, we want 3 for the string, 5 for the beads. So let's look at the first one. I see 3 and 5, that's a good start, but the 3 has to be the string. So remember, you move along the x-axis first. So when I'm going across to the 3, this graph says 3 beads, which is not what our ratio says. So that is not the correct choice. If I look at this next one, letter G, I should be going across the x-axis 3 for the string. So this is good. I see string on the x-axis, but when I go across, it's not 3, it's 5. So that one is not correct. For choice H, I want 3 for string on the x-axis. So if I go across, I see string, and I move to 3, so that's good. And then when I look at the y, it's 5, and beads are on the y-axis. So this is the correct choice. 3 to 5, 3 being string, 5 being beads. Look at the graph. 3 to 5, 3 is string, 5 is beads. And then for I, we want 3 to be string moving across, and when I look again, the x-axis has beads, so it's not the right choice on the x-axis. I'm going to keep going. I'm going to do one more page. Number 18, Regina purchases 1.7 pounds of turkey breast from her local deli for $5.99 per pound. To the nearest cent, how much did she spend in all? So it's $5.99 per pound. For 1 pound, she's buying 1.75 pounds. So you just multiply. $5.99 times 1.75 pounds. So this question is really kind of testing if you can multiply decimals. Okay, there's my first row. I multiplied the 5. Now I'm going to put a 0 to move over to the next digit. I'm going to multiply the 7. Okay, and now I'm going to multiply the 1. I need to put 2 zeros this time, and then I can move over to the 1. And then add. Okay, So now the last thing you have to do is you have to place the decimal. So you look at the numbers that you multiplied and you count the total number of spaces that the decimal is from the right. So 1, 2, 3, 4. So do the same in your answer. 1, 2, 3, 4. So we've got 10.4825. And this is money, right? She's buying turkey. So the directions said nearest cent, right? Because this isn't how we represent money. So with money, we would have two places. So it would be $10.48. So it's choice C. For number 19, Katrina uses 4.125 yards of fabric for each curtain panel. How many yards for 14 panels? So 4.125 for one. How much for 14? It's just multiplying again. So 4.125 times 14. Okay, so I did the 4. Now I'm going to put the 0 and multiply the 1. That's a 4. Okay, so same thing with the decimal. Count the number of places from the right. 1, 2, 3. So do the same in the answer. 1, 2, 3. So to make 14 panels, Katrina needs 57.750, and then you can have that 0 there or not, yards of fabric. For this one, the table shows the results of a survey on students' favorite school lunches. What fraction of the students surveyed said that grilled cheese was their favorite? So grilled cheese is 30%, and they're asking what fraction. So 30% as a fraction, percents are out of 100, so there's the fraction. When you look, that's not a choice, so that means you need to take 30 hundredths and find the fraction that's equivalent. So I'm going to divide both by 10, and that'll be 3/10. And right away I see that as a choice. For number 21, Tommy's batting average this season is 0.275. This means that he had a hit in 27.5% of his at-bats. If Tommy had 11 hits so far, how many at-bats? So this question is difficult. You have to remember to use the formula is, of, equals, percent, 100. And then you have to figure out, remember the top numbers are parts, the bottom numbers are wholes. So you have to figure out when you're filling in these numbers, are they parts or are they wholes? So the easiest one to fill in is always the percent. If it's got a percent sign next to it, it's easy to know where to put that. So I'll start on that side. I'll start with 27.5 over 100. And then the other number that we have to figure out is the 11. So they're telling us he had 11 hits. So how many at-bats? So we have to decide, are the hits a part? Is that going to go at the top? Or is it a whole and go on the bottom? So if those are the times that he hit, that's not every time that he was at bat. Those are called the at-bats. These are only the times he actually hit the ball. So this is a part. So 11 hits, and the question is, how many total times did he go up to bat? So that's the missing part. Instead of a question mark, I'm going to put an X so that we can solve for X. There are two ways to do this. You can solve this by finding an equivalent fraction using the arrows, or you can cross multiply. I'll do it both ways for you. So when you cross multiply, you make that x. So we would have 27.5 times x, and remember when you put the x right next to the number, that means that you're multiplying, equals, and then you multiply the other two numbers, the 11 and the 100. So that's 1100. So now since we've learned algebra, you know that we want to solve for x, and the way to solve for x is to get rid of the 27.5. So this is telling us multiply. The way to get rid of it is to do the opposite operation and divide. So divide both sides by 27.5. And I already figured this out on the calculator. So I will just tell you that when you divide 1100 by 27.5, it equals 40. So for this question, Tommy has been at bat 40 times. The other way you could have done this, if you didn't remember to cross multiply, is to use the arrows and try to solve an equivalent fraction. So we want to solve for x, so we've got to figure out how do we go this way. So we're going to start with 27.5 and we want to get to 11. So again, you can just use a calculator to figure this out, and that's what I did. To get from 27.5 to 11, you have to divide by 2.5 or 2.5. And so you do the same thing with the 100. Divide by 2.5. And when you take 100 and divide by 2.5, you get 40. So for this one, Tommy had 40 at-bats. For number 22, a machine has a large gear that completes a revolution every minute, and the small gear completes a revolution every 24 seconds. If the gears are currently aligned, how much time will pass before they are aligned again? So this is a question, we had one in class where it was the train times. One train comes every 12 seconds, the other train comes every 9 seconds. When do the trains meet again? So this is the same thing. This is asking you to find a least common multiple. But right away I noticed this says minute and this says seconds. And so we aren't going to be able to figure that out. We have to convert. So the easiest thing to do is take the minute and turn it into seconds. So there are 60 seconds in 1 minute. And so this large gear is going to complete a revolution, that's a turn, one spin, every 60 seconds, every minute. So there are the first 60 seconds, that's one spin. 120 seconds, that's a second spin. 180 seconds, that's a third spin. I'll do one more. 240 seconds, that's the fourth spin. Now let's work on the 24. So this is the smaller gear. The smaller gear after 24 seconds has completed one spin. And now I'm just going to count off by 24s. So 48, 72, 120, and right away I'm noticing that they both have 120. So after 120 seconds, the gears will be aligned again. They'll be passing at the same time. And so look at your choices. And you're going to think like, oh, they don't have 120 seconds here. But if you look at them closely, 120 seconds is 2 minutes. So that's the correct answer. And then for number 23, which of the following is the best estimate for the problem shown? So we're estimating, and for this one, I would use compatible numbers. What can you estimate these numbers to so that they work together easily? So for 151, I would estimate to 150. And then I need a number close to 29 that'll work well with 150. And I'm going to use 30, because if you take the zeros off for a minute, you would have 15 and 3. And so 15 and 3 are compatible numbers, so that means 150 and 30 are also compatible. So what is 15 divided by 3? And so 15 divided by 3 is 5, and so 150 divided by 30 is the same thing, just with a 0 on the end, so that's also 5. So the best estimate for that division problem is 5.